Hi guys, so let's keep going with the absolute value stuff, okay? The last page at the very bottom, we talked about how when you set up absolute value, the inside could be the positive version of the answer, or it could be the negative version of the answer. So when you solve it, you do the positive version and the negative version. So that's what we want to practice here. So even though in a problem like example 2, it equals 6x, it equals a term that has a variable, that's okay. You still approach it the same way. So let me see, how much room do we need to check? All right, we're going to need a lot of room to check anyway. So starting here, okay, we've got the positive version or the negative version. So it could equal positive 6x or negative 6x, okay? Just like we did on the other pages, just it's got an x with it. So it solves a little bit different. So then to solve, the expression can equal 6x or negative 6x. Okay? Oh, there's the bell. All right, so subtract. Trying to think. Oh, okay. So the way that they want to solve it, I had to figure it out, is they're actually subtracting 4x from both sides. So they're moving the x's over in order to solve. So we're subtracting 4x over so that the x's are together. Okay? And so we've got 6 minus 4 is 2x on this side. But be careful, this is going to be different. Negative 6 and negative 4 is negative 10x, okay? So as you solve, you do see that the solving actually comes out to different numbers and answers, just like it was on the last page. So then it's easy. We know that we solve for x by dividing. So in this case, we divide by 2 and get a 5. And in this case, we divide by negative 10 and we get a negative 1, okay? So right now it looks like these are our two answers. Okay, 5 gives us the positive version, 6x, and negative 1 gives us the negative version, negative 6x. But then this is where checking, like last page we went off to the side and checked, now we've got some room to check here. This is where checking helps us find those extraneous solutions, those extra solutions that actually don't come out as true. So now let's take these two solutions and let's check them and make sure they both actually solve out, okay? So let me erase this. So 5 and negative 1. All right, so let's check this. See, in the little box says, always check your solutions in the original equation to make sure they're not extraneous, to make sure that they come out as true. Okay, so the first one we had was a positive 5. So let's put a positive 5 in where x is for both of these. Okay, and let's check it. 4 times 5 is 20. 20 plus 10 is 30. Okay, 6 times 5 is 30. And then the absolute value of 30 does come out to a positive 30. So this one is good. X can equal 5. Okay, so the solution is, we know that 5 is one of them. We'll write that in a second. Okay, the other answer was negative 1 and negative 1. Okay, so 4 times negative 1 is negative 4 plus 10 is a 6. Okay. Yes, just want to make sure I did that right in my head. All right, and then this 6 times negative 1 is negative 6. Well, the absolute value of 6 is a positive 6, but this became a negative 6. So 6 and negative 6 are two different things. They are not equal. Okay, so this is not an answer. This is not a solution. It's not true, okay? And it's because the negative gave us a problem. The negative caused the numbers to change on us, and so that's why it didn't work out, okay? Now, some answers can be negative, but that's why you have to check, okay? So the solution is this 5 that we plugged in, and we have to reject the -1 that we put in because it's an extraneous. Let me make sure I spell it right. Extraneous. There we go. Okay? So it is an extra solution that math-wise worked out when we solved, but doesn't check. So it's got to go both directions, all right? So let's do it with a couple more problems, and don't forget you have to check. Okay? I know it seems tedious, but those are the little things we have to start doing in our Algebra 2. Okay, so let's do a couple more problems. All right, so I'm gonna, well, hopefully I have enough room. I may have to erase as I go just because I'm not sure if I will have enough room. So we've got two different versions. 2x plus 5 equals 11. And 2x plus 5 equals -11. Subtract 5, subtract 5. Same thing here. Okay, so 2x equals 6. X is 3. Or 2x equals -16. X is -8. Okay, so right now that's what it looks like our answers are, but let's check for extraneous. So off to the side, let me just do my check over here. Let me put in 3 first. 2 times 3 plus 5, does that give me 11? 2 plus 3 is 6 plus 5, so that's the absolute value of 11 equals 11. So they both come out positive, so we're good. Okay, so that one's good. Now let me check -8. 2 times -8 plus 5, does that equal 11? Okay, 2 times -8 is -16. -16 plus 5 is -11. But when you absolute value -11, it does work for us. So this comes out as positive and this is positive, so they both did work. So they're both these solutions, okay? For the next one, I'll probably have to erase this so you can check it somewhere else, or you can go off on the other side or something like that. Okay, so for this next one, 3x plus 18 equals 6x, or 3x plus 18 equals -6x. Okay, this case, let's get the x's together. So let's subtract 3x over here, subtract 3x over there, 18 and 3x. Oh, sorry, -6 and -3 is -9 instead. This is where we get our 3x. So it looks like x is 6, or x is -2. Okay, that's what it looks like. So now let's go off to the side and let's check that. Let me erase this check. Okay, so let's check 6 first. So the absolute value of 3 times 6 plus 18 equals 6 times 6. Okay, so we're going through and we're putting in this 6 for that x and for that x. That's the big thing, okay? So then we get 18 plus 18, and we get 36. That one's not good. Let me go back to this green one. So this is the absolute value of 36. Does that equal the absolute value of 36? Excuse me, does that equal positive 36? So yes, it does check. Okay, so that came out as 36. Those came out as 36, so 6 is good. Okay, and now I'm going to use a different color just because that one's running low. So now let's check this last one. I'm going to need some more room, so I'm going to go ahead and erase that. And let's check one more time. Okay, so the absolute value of 3 times the last one is at 2, negative 2, pardon me, plus 18 equals 6 times negative 2. Again, I'm putting the negative 2 in for both of the x's. All right, and then I just need to solve. This is negative 6 plus 18 is 12. 6 times negative 2 is negative 12. So the absolute value of 12 is a positive 12. But when we multiply this, we got a negative 12, and those are not equal. Positive, they're opposites, they're not the same, okay? So since these are not equal, since the answer turned that side negative, and that goes against absolute value, then that is not a solution, okay? So the only solution to this problem is 6, even though we could find 2 answers, okay? All right, so now let's just look at the bottom of the page where we're just talking about some graphing and some symbols and stuff, okay? And that's going to relate to some compound inequalities we've already talked about. So let's get this off the board. All right, so in the inequalities below, C is greater than 0. So that means C is positive. Numbers that are bigger than 0 are positive, okay? If you're given a certain type of inequality, then you can write it in 2 different forms. I call this the sandwich form. I guess it was last lesson. It was about, we talked about how you've got and or, and the word and has, you can say sandwich out of it because it has the word and in it, okay? Because you've got 2 ends and then you've got the middle. So this is what I would call the sandwich, okay? And, sandwich. And the way you can remember whether you make a sandwich or whether you make an or, which is just 2 separate inequalities, is that sandwich is less than sandwich, okay? So less than, okay? Less than makes a sandwich. So you take the positive version on the right end, and then you take the negative version on the left end. And then the sandwich, what you're solving, goes in the middle, okay? And then just like our sandwich when we graphed, okay, you had 2 ends to the sandwich, and then you had the middle, which is what we did with those compound inequalities last lesson, okay? So the OR problems are greater. If you have a greater symbol, greater, okay? It's really greater, but really, if you say greater, it helps you remember greater is an OR problem. So if you've got a greater symbol, then that creates an OR. So you've got 2 separate inequalities, the negative version and the positive version, and they go away from one another. Okay? Now, just be careful. The only extra thing with greater is that if you notice, the positive version looks exactly the same. AX plus B is greater than C. AX plus B is greater than C. But when you set up the negative version, you just have to, if you look carefully, if you do the negative version here, you also do the opposite symbol. Okay? So when you say AX plus B, when you do opposite here, you do opposite here. So it changes to less than negative C. Okay? And we're going to set this up and we're going to practice a few of them on the last page. So you'll see how we decide less than, greater, and then the setups as we do a few of them together. Okay? And then we'll practice more in class.